Hello everyone. Today we are going to put everything from Unit 2 together and finding all zeros. So we're going to be either given a zero or a factor or a root, or we are just going to be given a polynomial and we have to find all of those values uh, given the tools that we have right now. So if you're given one or more zeros, you want to use synthetic division to reduce that to a quadratic, and then you can use all of your solving skills in quadratics. And then if you're not given a zero, then what you want to do is use your calculator or the rational root theorem and find a zero from there or more than one zero. And then we always want to reduce down to a quadratic and then solve our quadratics. We want to make sure that we pay close attention to what the directions are telling us to find. So the main difference is that a factor needs to be written as like x minus p if that was your factor. Then you would write it in that way versus the rest will say x equals p or whatever number that may be. So if we're looking at this, we want to find all the roots of h of x. We have 2x to the third minus 2x squared minus 4x squared plus 40x minus 80. So you can always check to factor first and what you would be able to, but we're going to practice using the calculator. So if you plug this into your calculator or into Desmos, any graphing app, you will find something like this. And so there is other stuff going on, so if you plug into Desmos, you will see a little bit more. But this is what shows up. And what we take from this is we get this value right here of 2. So we know that that is a 0 or a root. And so we can use synthetic division to get from there this down to a quadratic. So we would use 2. We don't have any jumps. So we do synthetic division. And we should get that is 0. If you don't get it is equal to 0, then you've probably done something wrong if we've graphed it and we know that that's a value. So from there, we are now down to a quadratic. So this is going to read 2x squared. There's no x term, plus 40 is equal to 0. And so we want to solve this. We can solve by quadratic formula or square roots. So we can solve for, since there's no middle term, we can solve by square roots. So we can solve for that square term, and we're going to get x squared is equal to negative 20. And then now we need to square root both sides, and we will get plus or minus 2 root 5 I. So our roots are going to be plus or minus 2 root 5 I. So that's 2 roots because we have the positive and the negative, and 2. So make sure that you include your original in that problem. And note that on your calculator, it only crosses the x-axis once. That's because we have 2 imaginary answers. So we should always be checking to say we have 3 terms. So it's a degree 3, so we know we've gotten them all. Looking at another one, we're going to say find all the factors. So we need to pay close attention that it's saying factors, given that 3 and negative 4 are zeros of g of x. So if we are given these, then we want to use those with synthetic division to start. Does not matter which one you start with. So we're going to start with 3 just because they gave it to us first. We're going to use 10, negative 3, negative 136, 153, and 36. So when we multiply this out, we're going to get 10. 10 times 3 is 30. We're going to get 27. 3 times 27 is 81. And that is going to give us negative 55, and that will be negative 165, which will give us negative 12, and then 3 times negative 12 is negative 36. Again, we should be getting that our remainder is 0, and so if you are not finding the remainder of 0, then you need to go back and check your work and check whether or not you had any jumps in variable terms. We want to then use these same coefficients. We don't want to go back to the original and use negative 4. Okay, so we're going to bring this down. So we're going to say 10. We get negative 40. It's negative 13, which will give us positive 52. And so that will give us negative 3, which gives us positive 12. Again, that should give you 0, or else you are doing something wrong. So you should always go back and make sure that if they give you a 0, it should always give you a remainder of 0. So what we're left with is this quadratic. And we can solve this, so you can factor, quadratic formula, do anything that you want to do. We should always try factoring first just because that is more efficient. So we can try to factor this with 5x and 2x. And we're going to find that this is plus 1 and minus 3. So then if we were solving for x, we would get something like x equals negative 1/5 and x equals 3 over 2. Okay, so that's if we were solving, finding the solutions, finding the zeros. But it says find the factors, so we want to just use these two things here. And we want to use those. We don't want to use x plus 1/5 or anything like that. So for factors, we would write our answer as, using the originals, we need to write them as x minus 3, x plus 4. And this is all supposed to be on one line. I'm just running out of room. 5x plus 1 and 2x minus 3. So you just need to make sure you write those all in factored form if they are given to us that way. Lastly, we're going to find all the zeros given something like this. So x to the 4th minus 6x to the 3rd plus 9x squared plus 24x minus 52. We cannot solve this by factoring. They don't give us anything. So you can use the possible rational zeros, but if you notice, 52 has a lot of values there that we could potentially be testing over and over again. So what we want to do is we want to use a calculator, and the calculator will give us this. So we get two solutions there that we know are going to be real, and then we should recognize that we're going to have two imaginaries once we solve those down. But we're going to use these values, so we're going to use negative 2 and 2. And then we want to solve the rest from there. So I'm going to use negative 2 first. Does not matter which one you use first. We have 1, negative 6, 9, 24, and negative 52. Bring our 1 down. This is going to be positive 8. We get negative 16, which is negative 7, positive 21. Sorry, that should be a negative 8, so then we get a positive here. And so that should result in 25. That will be negative 50. We get negative 26, and that will become positive 52. And we get a 0 there. So if you're making sure that you always get that 0, if you don't, then you should either check for jumps or skips in the degrees, or make sure that you graphed it properly. Again, we want to use these coefficients. We don't want to go back to the original now, so we're going to use positive 2. So we're going to get 1. 2 times 1 is 2. We get negative 6. That's going to become negative 12. Positive 13 will give us positive 26. Okay, so now we're back down to a quadratic, which is what we want. What we want to make sure is that we are looking to factor. 13 factors only 1 in 13, so we cannot factor that, so we need to use the quadratic formula. So we're going to say negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 13 all over 2 times 1. And this is going to result in 6 plus or minus the square root. 36 minus 52 is going to be negative 16 over 2. And then that's going to give us, so we know that this is going to give us an I. And so we're going to result in I'm going to write these up here. So 6 over 2 is going to give us 3 plus or minus. Negative 16 reduces to 4i. 4i divided by 2 is 2i. Okay, so that would be from the imaginary part, but we also need to write, so we're finding zeros. So we can say x equals plus or minus 2 from the first two that we got over here and here. And then we have 3 plus or minus 2i. And again, each one of those consists of 2, so we know that that matches up with our fundamental theorem that says we should have 4 possible solutions. So brief review is that you always want to use the zeros that they give you. Always try to reduce down to a quadratic. If they don't give you any zeros, you can use the rational root theorem or using your calculator or graphing device to be able to find some values and then use synthetic division. I hope this helps you with solving and finding all zeros and factors.